Welcome to the Occupational Safety Leadership Podcast, Episode 11, Chemical Exposure Limits. Let's just dive right in. On today's episode, we'll talk about the chemical exposure limit published by OSHA. We'll also look at the ones from NIOSH, which are called RELs, the Recommended Exposure Limit. There's also a private group out there, the ACGIH, American Conference of Governmental Industrial Hygienists, and they have a threshold limit value. So there's been a lot of acronyms we've already said. And to top things off, a couple of companies have their own occupational exposure limits. Let's look at the first one here from OSHA. So this is also the only legally enforceable exposure limit that you have out there. And this is going to be called the PEL, the Permissible Exposure Limit. So most of the PELs were done about 1970. They have had a couple of ones change. And for the most part, they always seem to go down. They always seem to come up with more research out there, and we're just getting better as a society too. So we're coming up with more and more ways to sit down and measure these exposures, and of course what is safe and what is not safe. But the OSHA one is the only legally enforceable one out there. And when we look at a couple of examples, all these examples are going to be based off of a 8-hour time weighted average. And when we look at a couple of examples, acetone at 1,000 ppm parts per million. We could also look at ammonia at 50 ppm, and when you look at hydrochloric acid, it's at 5 ppm. Next, we'll talk about the ceiling. So the ceiling is going to be that limit that it can never go over. So you can have a time weighted average, and of course that's going to be based off of a 8-hour day. When you look at a ceiling, it can this here is going to be the limit that it can never exceed. And then when we also look at a action level there, so it basically indicates that the level of harmful or toxic substance which requires medical surveillance. So this is where we start to get into things like physicals. We start to look at increased industrial hygiene monitoring. You may have to go out and take some biological samples, also. So that's a real good time asking people for things like blood and urine and everything. So let's look at a couple of examples out there. So the example for hydrochloric acid is 5 ppm. That was also the time weighted average for the 8 hours. So sometimes it's going to be the same, whereas other times it's going to be that little bit higher for the ceiling because they factored in a 8-hour exposure limit. Boron trifluoride, 1 ppm. Also one that we'll talk about just a little bit is called the STEL, short-term exposure limit. And in this example, we have things like benzene at 5 ppm. When we look at the action level out there, this is where we have the increased for physicals, industrial hygiene, monitoring, all that good stuff. And a couple of examples that jump out. Formaldehyde at 0.5 ppm. So now we're starting to get smaller and smaller. Lead, when you look at micrograms per meter cubed, this is where you have to sit down and do some math afterwards and kind of say the person did or did not exceed the action level. And then finally, probably the smallest one that I've seen is going to be the beryllium, which is 0.1 micrograms per meter cubed, which is 0.0001 ppm. So as things get more and more toxic and awful and all that stuff, the exposure, of course, that you can be exposed to on a safe limit goes down. So let's switch gears just a little bit and look at the NIOSH, the recommended exposure limit. So the NIOSH ones are based off of a 10-hour work shift. The OSHA is an 8-hour. This is a 10-hour work shift. But this is also based on 40 hours per week. And so let's just kind of look at how, even though they're two government agencies, they still have a little bit of a difference in them. So ammonia is at 25 ppms for the REL. OSHA, it's at 50 ppms. Let's keep in mind that OSHA is the only legally enforceable limit out there. Benzene, we have 0.1 ppms, but with OSHA, we have 1 ppm. And boron trifluoride is going to be 0.1 ppms, which is also the same exact for the OSHA PEL, 0.1 ppms. So two different government agencies, two different ways of sitting down and looking at exposure. One is legally enforceable. One is a great recommended exposure, but not legally enforceable. Let's look at a private trade group out there, the American Conference of Governmental Industrial Hygienists, and they have a threshold limit value, which is also based on a 8-hour weighted average then. So let's kind of switch gears and look at the STEL out there, so the short-term exposure limit. So for ammonia, it's 25 ppms, but when you look at the OSHA, it's going to be 35. Hydrochloric acid is only 2 ppms for acetylene for this group, whereas OSHA, it's 5 ppms. Acetone is 250 ppms, whereas the OSHA one is 500. And nitric acid, 2 ppms, whereas the OSHA is 4 ppms short-term exposure limit. So again, we have a private group that comes in, and so they have their own way of doing things, their own standards, their own way of gathering data for exposure, and they've come up with limits that have you expose less. But again, this is not a legally enforceable means out there. So when we look at chemical sampling, you can do a atmospheric sampling when you kind of think about you're taking an air sample. You can do a wipe sample where you're looking for almost like some kind of like a dust or haze or something on some kind of a work surface. And that work surface can also be a computer mouse, a keyboard, a phone. So sometimes it's not only your traditional places where you think you're going to find something, but you can find something in a non-traditional place if the hygiene is not good in the workplace. And finally, when we look at like biological samples, it can be done with blood, with urine, with things. And now that you get more and more into asking humans to do things, you then have a harder time getting these samples. So when we look at the different sampling methods out there, there's going to be OSHA ones and also there are NIOSH ones. Make sure that you get help from a lab to understand exactly what standard that you're going to use, because you always have to follow a standard. You just can't go out and sample and then give some kind of feedback to people. You have to say, I scientifically followed this standard. This is exactly how I followed this standard, and here's the results based on that standard. You also have to send your sample to a lab that's certified to look at that sample, to extract that sample, to give that feedback, to find out. Once that you get all that stuff back, you then have 14 days to communicate it to the person who took that air sample, that wipe sample in the area, either blood, urine, whatever way that you took that sample. You have to then give that data back to the people then afterwards. And when we look at it, of course, there's going to be a lot of confusion between, is it a REL, is it a PEL, is it a TLV, the threshold limit value out there. I like to always use the very most conservative value that I can find out there, which is going to be the lowest exposure, because then at least I feel that I can then say I did everything I could to lower it as low as it possibly can. And because we care about the people. We're not worried about what you can and can't prove in court and all that stuff then. We worry about protecting the people then. And that's it. We then have episode 11, chemical exposure limits. Thank you for joining me so much, and I will see everybody some other time.